Hello, Math 7. I hope that you're having a really good day, and I hope that you're excited to expand our learning on exponents and squares. So we've talked about absolute value, and we've talked about squares and square roots. Let's review what a square root and a perfect square is again. So a perfect square of a number, remember, is the product of a number and itself. The product of a number and itself. Basically, you take a number like 5, and then you multiply it times itself, 5. We usually write that as like 5 squared with a 2, because it's two groups of 5 being multiplied. The square root of a number is one of its equal factors. And remember, a factor is a number or a set of numbers that you multiply together to get a value. So if I'm looking at the number 16, some factors of 16 are 1 times 16, 2 times 8, and 4 times 4. These are the equal factors, the numbers we can multiply by itself to get 16. So one of its equal factors is the square root. Square root of 16 is equal to 4. Let's think of some other examples. Okay, let's start with one that we're probably pretty sure of, about 25. We already said that 25 is the perfect square because it is the answer you get when you multiply 5 times 5. The square root of 25, okay, the square root of 25, so this would be 5 squared. The square root of 25 is 5. Okay. How about the square root of, or 13 squared? Let's do 13 times 13. 13 times 13 is 169. I'm sure one of you giggled. Okay. Square root of 169 is then 13 because it's one of its equal factors, 13 times 13. Try to fill one in on your own for the third one. Now let's go ahead and take a look at our exponents. We've been talking about them a bit, but let's just review some terminology. Okay, an exponent, the exponent is a number that indicates how many times the base is multiplied by itself, right? It's all about the base. So the exponent in this case is the 3. Exponent, it's the number that's superscripted, in superscript, above the first value. And this tells us it's an exponent, not just a regular number. The base would be the 2. It's the number we're multiplying. So the base tells us we're going to be multiplying 2's, and the exponent tells us we're doing that 3 times. So what this stands for, this is shorthand for multiplying 2 times itself 3 times. 2 times 2 times 2. 1, 2, 3 of them. Which would be equal to 2 times 2 is 4. 4 times 2 is 8. Cool. So now let's check out some of the patterns for negative exponents. Okay, so negative exponents are a little bit different because they're the inverse, okay, and they don't actually make it negative, not negative. So even though you see a negative sign and it's in the name, a negative exponent is actually indicating that we're doing the opposite of something. Because remember, a negative sign really means the opposite of. So we're doing the inverse or opposite of, okay? And what a negative exponent does is if we have an exponent like 10, all right, and we do 10 to the third power, that would be 10 times itself 3 times, right? Okay, a 1 with 3 zeros. 1, 2, 3. 10 to the negative third means we're changing that. That means that instead of being multiplying the whole number, we're multiplying the fraction. It says we're going to do the opposite of multiplying by 10, and that's divide by 10. We're indicating division with a negative, with a fraction bar. So it goes to the bottom, and it's like 10 to the positive third. Once you move a negative exponent to the bottom, it becomes a positive number, or 1 over 1,000. So it's the same value, but it's the division. All right, so let's give this a little bit of a shot. We're going to try a couple of different examples here, okay? So you're going to want to split this up the same way that I do, all right? I'm just going to divide this in half because I'm going to show you two different examples, okay? And I'm going to put 10s here. Okay. So split all three columns like I did. Sorry, I forgot to add a line for you. So the exponent, let's start with 10 to the third. Okay. Now we know that that's 10 times 10 times 10. That's called expanded form, right? Written all the way out. And that's a 1 with 3 zeros, 1,000. Okay. The decimal, that's just equal to 1,000, right? 10 squared, oops, I put 12. 10 squared, okay, is 10 times 10, two groups of 10, or a 1 with 2 zeros. Okay, and at this point, you might start to be guessing about a pattern. Then we have 10 to the first. How many groups of 10 is that? It's just one group of 10. And how many zeros is that? Just 1 0. So you'll notice that each time we are moving down, we're losing an exponent, we're losing a 0. That's because each time we're losing one group of 10, it's essentially dividing by 10, right? 1,000 divided by 10 is 100. 100 divided by 10 is 10. Now that brings us to an interesting case, 10 to the 0, okay? And 10 to the 0 power is just 1. Because if you think about it, again, the pattern is that we're dividing by 10. If we take 10 and we divide it by 10, we get 1, all right? 10 divided by 10 is 1. And in fact, any number to the power of 0 is always equal 1, okay? Because you end up dividing that number by itself. Now we get into the negative exponents. 10 to the negative first power, okay? We said that expanded form, that's just 1, and then the 10 moves to the bottom, right? Just like that, it's 1/10. The positive value for 10 to the first power was 10. Negative exponent value of 10 is 1/10. How do we write 1/10? Well, it's like 10 backwards. Write the number 10 and then put in the decimal appropriately. 10 backwards, all right? 10 to the negative second, okay? That's, instead of 10 times 10, it's 1/10 times 1/10, okay? Just equal to 100. 1 over 100, okay? That's 100 backwards as a decimal. I'll put the dot here. So you see that for 10 squared, it's 100, 10 times 10. For 10 to the negative second, or to the negative second power, it's the fraction, it's division of 10 times 10, 1/100th. Okay. And 10 to the negative third, you might be able to fill this in from the pattern. Okay. We move it to the bottom. It's written as 10 to the positive third, or it's equal to 1/1000th. Take the 1,000, write it backwards, you get your decimal, okay? I'm also briefly going to show you an example with 2s, okay? So really quickly, and if you can write this down, cool. If not, then do your best just to watch and follow along, Okay, we're going to do 2 to the third, 2 squared, 2 to the first power, 2 to the 0, 2 to the negative first, and 2 to the negative second and negative third. Okay? So expanded, 2 to the third, again, that's 2 times 2 times 2, is equal to 8. All right? 2 to the second, 2 times 2 is 4. And just like before, where to get from one line to the next, we were dividing as we reduced the number of exponents, here we're dividing. But we're not dividing by 10, we're dividing by 2, because that's the base we're working with. Okay? 2 to the first power, again, is just one group of 2, divided by 2. Right? Oh, I wrote a 2 here. This should be a 4. This should be a 2. Now again, we said that anything to the power of 0, 2 to the power of 0 is 1. Anything to the power of 0 is 1. 1,000 to the power of 0 is 1. So if I have 1,000 and I raise it to the power of 0, it's still 1. Okay? Now 2 to the negative first power. Now what we're going to do is take it and we're going to put it in the bottom. 2 in the bottom, that's 1/2. What's 1/2 as a decimal? 0.5. Okay? 2 to the negative second, it goes in the bottom and becomes positive. Once we move it to the bottom, it's a positive number. It loses the inverse because we've done the inverse. And 1 over 2 squared is 4, 1/4. 1/4 is 0.25, which is half of 0.5. And 2 to the third, we move it to the bottom, it becomes positive. And you get 1/8, or 1.25, half of 25. So you'll notice 8, 1/8, 4, 1/4, 2, 1/2, and 1. Okay, let's do a little bit of extra practice. Here we're trying to write it as a fraction. Now, whenever you see a negative exponent and you want to write it as a fraction, there's 2 ways. I have 10 to the negative fourth. The first way, and usually the easiest, is just when you see the negative exponent, you can think of it as, oh, that should indicate that you need a fraction bar. Think of that negative as actually a fraction bar. All right, so I need a fraction bar, 1 goes in the top, and then we rewrite this in the bottom as a positive. So another way, an equivalent way of writing 10 to the negative fourth power is 1 over 10 to the fourth. Okay, and that's equal to 1 over a 1 with 4 zeros. 1, 2, 3, 4. Okay, 10,000. So these are equal to each other as well. 2 to the negative third, 1 over 2 to the positive third. Okay, 2 to the positive third is 1/8. 10 to the negative second goes right in the bottom. Usually if they ask you to write it as a positive exponent, they want this form. Okay, and 4 to the negative second is 4 squared in the bottom. Okay. Now let's look at the pattern below and try to extrapolate. So our pattern is we have 10 and 2 zeros, 10 squared, 100. 10 to the first power, 1 0 is 10. 10 to the negative first power, look, it's backwards, right? 1/10. Here it's 1/100th. So 10 to the negative third is 1,000th. So we're going to take a 0, 2, 3 zeros, 1,000, write it backwards, and put a decimal in. It's 1/1000th, right? A 1 in the 1,000th place. Okay? Let's expand on that pattern a little bit below. We did 10 to the third. 10 to the fourth then would be a 1. We could write it as a fraction by saying 1 over 10 to the fourth. Bring it to the bottom and make it positive. Right? And then the decimal would be 4 zeros backwards. We're writing it backwards. And a 1. So the decimal value is 1/10,000th. Right? And same thing here. We're going to add another 0. 1, 2, 3, 4, 5 zeros and a 1. Put in our decimal and write it as a fraction. 1 out of 10 to the fifth. Okay, so remember, when you're writing negative exponents, a negative exponent means that you create a fraction, you're dividing, instead of multiplying, it gets smaller, all right? And as soon as you take the number and rewrite it as a fraction with the value in the bottom, it becomes positive, okay? So it doesn't, a negative exponent doesn't make a negative value. It indicates to make a fraction, okay? Good luck with your practice.